If you thought Calculus 1 was exciting, wait till you see Calculus 2, cause in this video, we're doing Calculus 2, but in Minecraft, so the retention isn't worse. This is the portal to Calculus 2. Let's hop right in. This is Calculus 2. The first step of Calculus 2 is integrating. We talked about that at the end of Calculus 1. Simple U-sub is the first step. Simple U-sub is simple. In this example, we have an inner function, and that can be u, usually. Du is the derivative of u. We have a dx, which is du, so we can substitute for u to the power of 3. We integrate and then substitute u back in. And never forget your plus c. Area between curves is one of the many applications for integrating. In this example, let's say the purple block is y equals x, the green block is 1/10 x squared, and the yellow block is where these two lines intersect. Here we have those two lines, the straight line and the curved line, but what's the area between the two? The easiest way to estimate is to take these three red sections and figure out what the area is, length times width, because they're simple triangles and rectangles, but that's not very accurate. The better way is to integrate. The formula for area between curves is f of x minus g of x, where f of x is the top function and g of x is the lower function, from 0 to 10, because that's where the intersects are, 0 to 10. X is the top function, and 1/10 x squared is the bottom function. We then integrate, and we get this function from 0 to 10. We do this function and plug in 10 to x, and then subtract that function and plug in 0 to x. Luckily, I used Desmos, and there should be just under 17 blocks in between these two curves, times 4 because I scaled up this graph 4 times. So there should be 67 blocks, but when I counted, there were only 55 blocks. This is because there's still a lot of error in this graph. Imagine a function that goes like this. It would cut out half of this block, and maybe half of this block, and half of this block. So what we did here was basically we had this estimation, and then instead of having 3 sections, we had 10 sections. If we were to scale this graph 1,000 times bigger, so it went all the way down there and all the way up there, then we would get much closer to the number of blocks we'd actually expect. The reason integrating is so powerful is because it cuts this block into an infinitely small number of pieces and integrates exactly how much area is between these two curves. Minecraft is not a good example for this because there are no curves or circles in Minecraft. Who could have guessed? One of my favorite examples of integrating is if you're building a sidewalk. Each square is easier to measure the area of concrete. It's just length times width. Length times width for this square too. Length times width. It's very simple. But when we have a road that curves along the sidewalk, and we get this edge that's cut off, then we come into a problem. You don't want to do length times width, or else you include all this extra concrete that you don't need, and you'll waste it and waste money. If you do a triangle, you'll get closer, find the function of this curve, and integrate it to get exactly how much concrete you need to buy. Next up, we have volume by rotating. Imagine if you took the coordinate plane and flipped it up on its side. Let's imagine a curve x squared. And now imagine if we rotate it all around this mesh to complete a bowl shape. What's the area of that bowl shape? It would be very hard to estimate, especially if this was an exact x squared curve. But we can use the formula pi r squared dx. From a to b. A is the lower limit and b is the higher limit. And r is the function because that's the radius. Y equals x squared. We can plug in those into the formula from 0 to 3.3 and we get approximately 246 blocks. So if we were to fill in all these diamond blocks all the way around, we should use 246 of them. It will be a little bit off because it's Minecraft, as we saw in that example over there, but it should be pretty close. One of the biggest questions is, how do you integrate? Techniques of integration is used whenever integrating cannot be done easily. Before you do techniques of integration, you must remember to do simple U-sub because it's a lot more simpler than techniques of integration. There are 4 main techniques of integration. The first technique of integration is trig identities. These are used whenever you have complex trig functions that cannot be integrated easily. They can be replaced with other functions that can be integrated easily. For example, cosine squared x plus sine squared x is hard to integrate, but it equals 1, and 1 is easy to integrate. Another example is sine 2x equals 1/2 times 1 plus cosine 2x. There are much more, but all these simplifies the complex integrals so that you can integrate more easily. After trig identities, it's trig sub. Trig sub is used when you have the square root of a function with two parts in it, an a squared or a u squared, a plus or a minus. This comes from the Pythagorean theorem. You draw your triangle and you figure out which side is a, which side is x, and which side has the square root side on it. After substituting, it becomes a trig identities problem, which is just these steps again. After trig identities and trig sub, we have partial fractions. Partial fractions are very helpful because you can split up fractions. Let's say we have this integral. Imagine integrating this. This wouldn't be easy. You can't do u sub and you can't do trig identities or trig sub. So you have to split up. You can do x plus 1 on the bottom on this side plus x plus 4 on the bottom of this side, and the numerator is a and b. Then you can solve for a and b, setting it equal to itself, and then you get a new integral that's much more simple to integrate. In this case, it will just be the du integration, which is much more simpler than trying to integrate this. Integration by parts is the last part of techniques of integration. This is just the reverse product rule from deriving. The integral of u dv equals uv minus integral of v du. This is the formula. Choosing u can be done using LIATE. L for logarithmic functions, I for inverse trig, A for algebraic functions such as x squared or x, T for trigonometric functions, or E for exponential functions. After doing this, there's less stuff in the integral, so it's easier to integrate. I wonder what happened if we walk through this painting right here. Like, it's not like there's going to be like a doorway on the other side. Wow, how original. I wonder what's behind the door. This is the dark room of summations. Summations add numbers from something to infinity. You can use calculus to figure out if it converges or diverges. It can either converge to a number or diverge to infinity. And that's all I really know about this chapter because it didn't make much sense to me. Let's escape from this place. And it looks like that's the end of Calculus 2. Thank you so much for watching. Maybe I'll make Calculus 3, but in Minecraft, so the retention isn't even worse. See you next time.